All right, guys, this is the second part of lesson 1-1 on functions and continuity. And so if you weren't in class for the first part, or if you didn't watch that video, probably should go back and do that now. Now let's quick review. 1-1 part 1 here had domain and range. That was a big part of it. And so which one of those represents the x values? Hopefully you thought about that and picked domain. We also talked about one-to-one and onto functions and how to know if a graph, when we're looking at it, is one-to-one, and how to know if we're looking at the graph if it's onto. And so how can I quickly check a graph to see if it's a one-to-one function? What test can I use? Hopefully you remembered it was the vertical line test. All right, so today is more functions and continuity, except for it really isn't. Today is really all about notations, how we write out sets. All right. And so a set of numbers, like the domain and range, we did this. We talked about a set of numbers. We talked about how to write things in sets. And we use mostly algebraic notation when we did it before. It is what you were used to. It didn't seem foreign to you when we did it that way. Maybe the brackets seemed weird, but the rest of it probably made sense to you. All right. Today we're going to add in set builder notation and interval notation. And real quick, to kind of just give you a real quick rundown of these three, and then we'll practice some more. If I have a number line, so we'll start at 0, going this way would be negatives, going this way would be positives. Sorry, left negatives, right positives. Right. And then let's just do the open circle, and it goes to the right. Now, let's review some things. Open circle, does that mean it's included or not included? Open circle, not included. Going to the right, is it getting bigger or getting smaller? It's getting bigger, so it's greater than. All right. And so for algebraic notation, I would just say, excuse me, I would just say x greater than 0. Right. Set builder notation, I want to say x such that. That's what it kind of is. It's just you're defining the element. Different, various maybe places you'll use this in life. You'll have to start that way. All right. X such that x is greater than 0. So it still uses that algebraic notation. In fact, both of these probably should have the brackets around them for set. Interval notation is much more strange. If you move on to like a calculus teacher like Mr. Jameson would hate that I called interval notation strange. He probably uses it more than any other type of notation. All right. So it's all about where you're going in math world, whether you'll use a ton of interval notation. But it kind of starts at 0 and then goes forever all the way out to infinity. And then we're going to do it like parentheses. And whether you use parentheses or braces kind of will matter whether you include 0 or not. So we're using this parenthesis, this rounded off parenthesis, because it's not included. 0 is an open hole. All right. And we'll talk about that more here in a minute when we work on just interval notation. So the first one's algebraic. Again, this is kind of review. You know these, whether you've done it in a while or thought about it in a while, it's a whole different thing. But, open circle, going to the left, so it's x is less than 2. Closed circle, going to the right, so it's x is greater than or equal to -2. This is one that's maybe tricky because it's going, both left and both right, but there's this missing area in the middle. And so we use the word or, all right? And so it starts at 0 and goes this way. So x is less than, now it's included. So x is less than or equal to 0. Over here, x is greater than 2. This is one that's very strange, maybe. And we'll give you one of these on the homework because it's good to practice. But it's in between. So it's kind of an and. But it starts at -4, goes to 4. So it's everything in between, right? Those two is included. So the x is in between. So it goes from -4 to 4. X is in between. And so these things go the same way. And it's not included. So x is greater than -4, less than or equal to 4. But, once you get used to, writing the x in between, it kind of makes making those less than and greater than signs a little bit easier. And then all real numbers. And again, we said you could use the double bar R there. Let's talk about set builder notation. Set builder notation is very similar. All right. You are the braces, and we could have used the braces in the last one. That braces that start and end it just indicate that it's a set of numbers. All right. And they just use this little symbol, this little straight line symbol is read as such that. This little strange E looking thing is an element of. We'll talk about that down here at the end. All right. So this would be read as, it's just the same thing. X is less than 2, right? So X such that X is less than 2. You're just defining what you're talking about. We're talking about X here. All right. So this would be like a domain. X is greater than or equal to negative 2. So these are all the same inside here. Still have the or, still have the and. Down here, we have the X is an element of double bar R, and they're explaining the double bar R is a symbol for all real numbers. All right. Again, if you weren't in class or haven't seen me draw that, I just draw it like this. All right. Double bar R, all real numbers. And then the one that we're going to talk about probably the longest right now, we're not going to necessarily use it the most in Algebra 2 class, but it's the newest to you. It's interval notation. And so it goes to this first one. Let's talk about this first one. It goes to the left forever. So the farthest left it goes, and I'm going to read them all from left to right. Farthest left it goes is negative infinity. Goes forever. All right. Farthest right it goes is 2. Now the infinities, we're always going to put that rounded off bracket on. So because it's infinity, it gets a round off bracket. The 2, why a rounded off parenthesis right here? And it's because it's not included. I use the squared in one, the bracket or brace, because it is included. Coach Kearns, when he explains this to his class, he says, the rounded off is kind of like you got a noodle arm. All right, you're kind of not very strong. The bracket is like you can flex and be strong, and it's a more strong, tougher looking thing. So it includes it, it holds it in. All right. I've always thought that was wacky, but it does help me remember it, and I can teach it that way. So if it helps you, awesome. All right. Again, I'm going to work from left to right. So this one, negative 2 to infinity. Negative 2 is included, so brace or bracket there. Looser parenthesis, always around an infinity sign. Left forever, so negative infinity. Stops at 0. Starts again at 2. All right, it goes on to infinity. 0 is included. 2 is not. And then this symbol that looks like a U, all right, is called union. Basically, think of it as the word or. It's a fancy symbol for the word or. All right. And again, how much you use that is kind of going to be mattered on how much farther you go in math. All right. But if you can see it, it for passing this assessment we're going to have, awesome. In between is easy. I'm working from left to right. So it goes from negative 4 to positive 4. The negative 4 was not included, so loose or rounded off one. Positive 4 is included, so harder, squared in, bracket, or brace. And then all real numbers is a little bit stranger. It's a little bit easier to write the double R, but negative infinity to positive infinity, all infinities get round off things. So not exactly super hard. You'll get used to this. Hopefully you're taking some notes right now. It's not super hard. It's new to you. All right. Example 6. Example 6. Write the domain and range of the graph in set builder and interval notation. So we'll do the domain on this side, and we'll do the range over here. And so first, let's use set builder. Set builder, I'm a little more comfortable with because I use algebraic notation all the time. All right. Again, if you were a calculus teacher, you maybe use interval notation more, and so you're more used to that. All right. And so the domain, all right, is the set of x's such that, now what is the domain? As this goes up very fast, it's going to the right very slow, but it never stops going to the right. Same thing when I go to the left. It never stops going. It's going up faster than it's going left, but it never stops going left. It never stops going right. All right. And so that would be the set of all reals. Now, the real way to write that would be x is an element of all real numbers, right? If you just write x such that, and then you just write the double bar r, though, I'm never going to mark that wrong. So if you don't use the element symbol, I'm going to be okay with that. All right. If you're going on to be somebody who works in different fields, maybe you need to practice that more. All right. How about, while we're over here, let's just do interval notation. And so all reals interval notation means it's going, the farthest left it goes is negative infinity. The farthest right it goes is positive infinity. And then infinities always get the rounded off ones. And so that is the interval notation. Range. It goes up forever. Forever. Never stops going up. Does it go down forever? No, it doesn't. It doesn't go down forever. That would be too convenient. It goes down, 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 stop. So how low? What's the lowest it goes? Range is y's. Y's are up and down. What's the lowest it goes? -6. And so for set builder notation, it's the set of y's such that y, and now it goes up forever, so y is greater than or equal to -6. It's supposed to be a 6. And then we end with the other set. Range. Now let's do it in interval notation. Interval notation, all right, it goes from low to high. So lowest it goes is -6. Highest it goes is positive infinity. All right, infinities always get the round off ones. Is -6 included or not? It is included, so it gets the more squared in bracket. All right, you try. If you need to go back and look at the last example, go back and look at it, but take a second right now and eliminate some and try to figure out which ones it is. All right, hopefully you successfully figured out what it was, and you can pause the video now if you haven't still and need time to work. All right, but let's talk about domain. For me, domain's easier here. It goes left forever, goes right forever, so the domain is all reals, right? And so it can't be D. D's eliminated, and it can't be E. So just from knowing the domain was all reals, which is not super hard to see, I've eliminated 2 of my answers. And so let's talk about the range. The range, it goes down forever, all right? But it comes to 0. So y is less than or equal to 0. Well, it sounds to me like A is good. It sounds to me like A is exactly what I just said. Down forever, all right? Down forever goes to 0. Ooh, B and C look very, very similar. They're both all reals with the domain, and they look like they're the same with the range. Uh-oh, what's the difference? The difference is just around the 0. So which one's right? Is 0 included? It is included. And so this one is not, we'll switch colors here. Not good, but this one is all right. And then down here, range is not all reals. And so also F cannot be the answer. So A and C are the right answers. All right, so let's look at a discontinuous or a non-continuous graph here and do the same thing. All right, so domain we'll do on this side again. Range we'll do over here again. All right. And what is the domain? Well, it goes left forever, and it goes right forever. But there's this like missing area right here. And so it goes left forever, but starting here at x, domain is x. That's x is -1. So how do we write that? So the domain is x such that x is less than -1. Now, is it less than or equal to? It is an open circle, so it's just less than. Now, it starts again over here, and so this is where I want to use the word or. it goes all the way from here to right forever. So starting at 0, because that's where x is 0, forever getting bigger. So or x greater than 0. And now it's a set, so I'm going to write it as a set, and I'm done. Interval notation. All right, let's just break it into parts. Looking at this one, it's negative infinity all the way to negative 1. Negative infinity all the way to negative 1. Now, infinities always get the round off one. Negative 1 not included, round off 1. Instead of writing or, I'm going to do that little u thing. And then it goes from 0. Oh, I was going too fast there. 0 to positive infinity. All right. Infinities always get the round off one. 0 is included, so it gets the more squared embrace. Range. Range looks like it goes up forever and down forever, but there's this missing hole right here. So the range is that same or thing. The range is the set of y's such that starting here, which is y, negative 1, for down forever. So y is less than, not or equal to, it's an open circle, or y is greater than or equal to, it starts here, greater than or equal to, it goes up forever, and that is y is 2, so greater than or equal to 2. And sorry, I kind of got smushed over here, so I should have wrote that like in a straight line, like kind of around a room. I apologize. All right, interval notation. Up from down to up. So down far as it goes, negative infinity. It goes all the way up. What is y there? We said it was negative 1. Negative infinity always round off. All right, negative 1 not included, round off. Or is the little u symbol. And then it goes from 2, squared in, 2 is included, 2 to positive infinity, round off. Give it a try. Take a look at this one. Pause the video here. Answer if you're, and good luck. All right, hopefully you've had a chance to take some guesses here. If not, you can continue to pause the video if you want, but I'm going to try to explain it. To me, I see it goes up and down forever, so the range is easy to me. The range is the double bar R. The range is all reals. All right, so that eliminates things. I know right now the answer can't be A. I know right now the answer can't be C. All right, everything else, the range is all real, so it's a potential answer. All right, but I know it can't be those two. And so the domain is everything getting smaller from negative 1 and bigger from positive 1. And so this is like in between negative, and that's like everything it's not. And so that one's bad. I don't want that. I don't want B. All right. And so now what I just said is it's smaller than, less than, or equal to negative 1, greater than or equal to 1. So I'm just noticing right now it's definitely F. That's exactly what I just said. All right. I know it's not all reals, so I can go ahead and eliminate E, get E out of there. And so the question really just becomes, does D get included or not? And so does it go from negative infinity to negative 1 and then include negative 1? Yes, it does. Include positive 1 and go, yes, it does. And so D is okay with me too. And so those are the two answers for that one. So just practicing notation, only I think 5 problems tonight. If you are going to do both assignments as one, that's just fine. Maybe because I'm still, maybe make a notation on that when you turn in your homework that you are doing both assignments as one. Good luck.